Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this fifth lecture of module 2 on water rock interaction or rock water interaction. In previous lectures we have discussed about concept of chemical weathering involving water and various processes of chemical weathering. In this lecture we are going to elaborate some of weathering indices and concept of weatherability, which will be useful for semi-quantitative and quantitative evaluation of weatherability for rocks or rock strata called by water rock interaction or rock water interaction. In these lectures we are going to discuss about weatherability and weathering indices. For this, we are going to cover weatherability, concept of weatherability, then concept of weathering indices, then categorization of weathering indices, then significance of weathering indices in engineering geological application. Friends, we have already discussed about the concept of weathering in our previous discussion. As you know, the weathering is a process resulting or causing the weakening of rock or rock strata or even soil layer, and the weathering causes significant changes in chemical, physical and mechanical properties of rocks or rock strata or even soil layer. It is necessary to recognize this process, which will helpful in engineering geological assessment or assessment of engineering property of rocks and rock strata or stratum. If we are going to see the different type of chemical indices concerned to the weathering as chemical weathering indices, if we are going to see different type of indices as categorization of indices, we can able to classify weathering indices in three broad groups. First is chemical weathering indices. Second, mineralogical and petrographical indices. And third, engineering indices. These indices are actually the evaluation of evaluation of rock or rock strata from weathering point of view. It means this is one approach for quantifying the impact of weathering. So one by one we are going to discuss. In very early Riche in 1943 was proposed a chemical weathering index. Chemical weathering index such as weathering potential index and the product index. These indices are this approach to determine this weathering potential index is actually based on chemical composition of rocks. Based on chemical composition of rocks or rock strata. As you know, the rock is comprised of different minerals having different chemical composition such as Ca, such as Na, such as Mg and many. So as per the concept proposed by Riche in 1943, the weathering potential index can be determined based on the ratio of certain chemical compounds such as K2O plus Na2O plus CaO plus MgO minus H2O multiplied by 100. Then this whole thing was divided by the addition of molar proportion of this SiO2 plus Al2O3 plus Fe2O3 plus FeO, TiO2 plus CaO, MgO, Na2O and K2O. This molar proportion of this you have idea in chemistry. This type of estimation is able to provide this weathering potential index. Another index suggested by this Riche in 1943 very early, product index Pi. Pi is simply SiO2 multiplied by 100 divided by SiO2 plus Al2O3 plus Fe2O3 plus FeO plus TiO2. This WPI, weathering potential index and product index, are able to provide the chemical stability of the rocks and indirectly going to define about the weathering. Here we are going to see the decreasing weathering potential index implies decreasing mobile cations and increasing hydroxyl cation. If increasing hydroxyl cations, it means starting promoting the weathering. Whereas decreasing in Pi indicate decreasing silica content with the onset of the weathering. So in this way we are going to quantitatively identify the weathering potential or the weathering effect or the weatherability of the rock. Ruxton in 1968 proposed the ratio of silica and alumina for assessment of weathering indices. Beta dash is equal to A weathered by A fresh plus CaO plus MgO, where A is representing K2O plus Na2O divided by Al2O3. Further, Parker have approached this problem, and Parker have suggested proportion of the major alkaline metals and their bond strength, with oxygen used as the weighting factor with respect to oxygen. This index is considered to be applicable for acidic, intermediate and basic rocks or rock strata in all conditions, all situations where hydrolysis is the main agent of the silicate weathering. And this Parker index WP, after Parker, you can use this 2 as a subscript. So this Parker index can be determined by simply 2 Na2O divided by 0.35 plus MgO divided by 0.90, then K2O divided by 0.25 plus CaO divided by 0.7. Further, Mura in 1973 have considered the difference between the mobility of ions in ferric and ferric state and proposed on the basis of this concept ferric and ferrous state. He had proposed one index, and this Mura index, Mi is after Mura index. This is simply NO plus MgO plus CaO plus MgO plus Na2O plus K2O and divided by Fe2O3 plus Al2O3 plus 3H2O. In this way, with help of these chemical compounds and the arrangement of chemical compounds, we are able to estimate semi-quantitatively the weathering potential. In the same direction, further number of researchers have proposed different concepts. For example, again in 1985, Roche et al. Suggested a index known as Laxavian index, and Laxavian index is a very simple type of index. This is simply ratio of a weathered and a fresh rock along with CaO divided by MgO, where this data indicates about K2O plus Na2O divided by Al2O3. You can consider this K2O like this, Na2O like this, and Al2O3 like this as a subscript. Jayawardhane and Ijawa in 1994 again attempted the same problem, and he had assumed possible relationship between Al2O3, SiO2 and TiO2 and put forward an index of chemical weathering as a silica titania index. SiTi index is a very simple. It is a ratio of SiO2 by TiO2 divided by SiO2 divided by TiO2 plus SiO2 divided by Al2O3 plus Al2O3 divided by TiO2. This SiO2 divided by TiO2 on upper side, then divided by this whole thing, is able to provide SI-TI index. Further, in 1996, Irfan have defined this weathering concept based on mobile and immobile element during weathering and develop a mobile index. This mobile index is a very simple. This I move after this Irfan. Mobile phrase minus mobile weathered, and where this mobile phrase and mobile weathers are the total K2O plus Na2O plus CaO contained in phrase and weather rock respectively. So these are some of the attempts related to development of different chemical index, plural of index is indices. In addition to this, we have several such attempts without entering in any destructive work or any testing work. On the basis of chemical composition, we are able to estimate weathering potential of rock or weathering susceptibility of rock under the term weatherability of rock. As we have already discussed, we have three types of indices. One is a chemical based, chemical composition based. Another is mineralogical and petrography means textural based. And another is engineering based. Or in another way we can say that engineering geological indices. So next type of indices based on mineralogy, mineralogical and petrographical weathering indices. This mineralogical and petrological weathering indices depends on the mineral constituents and their arrangement. In this direction, the LUM in 1962 has attempted the problem and proposed a mineralogical index based on the degree of decomposition by taking ratio of weight of quartz and feldspar. And friends, as we have discussed, the resistance of the quartz and feldspar are far different. In previous discussion, we have discussed granite consisting of quartz and feldspar are able to resist water in different capacity. Quartz is more resistant than the feldspar. Feldspar interacting with the water in chemical weathering is going to produce clay mineral. So it means the feldspar mineral is more sensitive to the water rock interaction in comparison to quartz. So he has proposed this index. Degree of compositional index is simply NQ minus NQ0 divided by 1 minus NQ0, where this NQ and NQ0 are the weight ratio of quartz and feldspar in weathered material. Soily material means the fully transformed rock in form of soil, and fresh rock specimen or sample. Another attempt made by the Mende in 1966 based on the petrographic petrography and proposed the petrographic quality index. This petrographic quality index is actually differentiating the unsound from the sound mineral present in rock. This gives as index simply Ki is equal to summation of this Pi xi, where this range upper boundary as n I is equal to 1. Then this divided by again summation of n and j is equal to 1, then Pi yi. It is simply the ratio of sound mineral in percentage divided by unsound mineral along with the voids or pores and along with the fissures presented in percentage. So sound mineral, with if we are going to see a rock, we are having some intact grains and some voids present, gaps. Then we have sometimes we are having some fissures also. So the estimation of the fissures, estimation of the voids and unsound minerals means the minerals which are more susceptible to water rock interaction or the weathering. Where this n value of the xi or the percentage of sound mineral are minerals having favorable influence on mechanical response of rocks or rock strata, rock stratum, and m value, this n value next of this yj are the percentage of altered minerals or weathered mineral, and coefficient of pi and pj are the waiting to take account of influence of individual minerals and mechanical response of rock and rock stratum. So it is very simple, and again I try to write this for simplification due to here the typing limitation. This Ki is equal to summation I is equal to 1 summation of Pi xi divided by summation n, here j is equal to 1, here pj and yj. Descriptions we have already discussed. In Onodera et al. In 1974 further introduced the density of microcake. Density of microcake based index for physical weathering along a microscope traverse line. This simply PCR or ROCR you can recognize is equal to simply 100 into total width of cracks divided by length of measured line. It is a very simple. You can also try in microscope. In microscope we are having, if you see any microscope, any rock slide under microscope, then we are having different type of grains, maybe in contact or maybe slightly away from each other like this. These are the constituents, mineral grains, and this zone is a void. We are taking here traverse along first traverse, second traverse, third traverse, fourth traverse. In this way, if this individual first traverse, we are going to calculate this density of microcrake along this first traverse, then density of micro. These gaps we are recognizing as microcrakes or voids or pores. In this way, we are going to see the distribution of the microcrake in view of the density. Further, Irfan and Darman in 1978b proposed a very simplified petrographic index. And this petrographic index is a very simple. IP is equal to SC presented in percentage divided by UC also in percentage, where this SC represents sound constituents, means unaltered resistant mineral present in a type of rock. Here we have taken this Irfan and Darman have experimented on the granite. And UC is U for unsound constituent, C for constituent, means secondary minerals such as muscovite or iron oxide, including microcracks and voids resulting chiefly from the weathering. This is also very simple thing. If you are able to identify unaltered resistant mineral and secondary or partially altered mineral, then we are able to calculate this IP proposed by this. So these are very simple approaches for anyhow in engineering geology. We are going to translate the geological information in quantitative way so that the other members of team can utilize. So in this direction, this is an small attempt to quantify the weathering or weathered ground based on chemical approach, based on mineralogical approach, and based on petrographical approach. Further in this direction, Cole and Sandy in 1980 proposed a concept, a index based on the secondary mineral rating. He has started rating the secondary minerals for a purpose regarding the assessment or evaluation of the road aggregate performance. Based on the stability of the secondary mineral, he has proposed RSM is a summation of P into M and this whole divided by TR, where this P is a percentage of secondary mineral, M is stability rating of minerals, and TR is a textural rating. His approach was purely based on the concept of rating system or providing some weightage. One very practical approach was developed by Haworth and Rowland. He has proposed a innovative concept in terms of textural coefficient. This textural coefficient is nothing, it is simply quantitative estimation of different petrological property of rock, like grain shape, grain orientation, degree of grain interlocking, and relative proportion of grains and matrix as a packing density. So overall, these parameters belonging to texture of rocks, and this Haworth and Rowland in 1987 has proposed textural coefficient to quantify the texture of rock. Although the textural coefficient has not given more weightage to the mineral constituent, this textural coefficient we have widely utilized in field of engineering geological response estimation of rocks and rock strata. If we are going to see here, we can see one correlation here, the textural coefficient and the uniaxial compressive strength of some of rocks belonging to metamorphic, igneous, sedimentary, and again igneous, effusive. Here, on the basis of literature and others and proposed concept and tested on number of rock, different researchers have proposed this line, regression line. You can see this regression line indicates as there is increment in textural coefficient, R means, and there is increment in compressive strength. So in another way, if we are trying to summarize, we can say that the compressive strength, particularly when estimated in uniaxial condition, uniaxial compressive strength is directly proportional to textural coefficient. It means this textural coefficient we can utilize a very important parameter for estimation of the mechanical response or strength response of rock strata. This textural coefficient we can utilize as a tool for characterizing the weatherability of rocks. In addition to this, we are having engineering indices. Engineering indices is a very simple based on some instrument and other some methods. One of the approach made by the Liu in 1966 based on ultrasonic velocity in monzonitic rock, igneous rock, and in particular this experiment he has suggested K is equal to, K is a coefficient of weathering. This coefficient of weathering is a simple. This K is equal to V initial minus VW divided by V initial, where this V0 is the velocity of ultrasonic wave in fresh rock and VW is the velocity of ultrasonic wave in weathered rock. We will discuss in our future classes about this, but for your information and for your basic knowledge, here I try to explain. Here the ultrasonic wave measurement we have very simple. We have to cap two sensors going to change the electrical energy in mechanical energy and allow the wave to travel through this and received by another end mechanical energy. Then mechanical energy changes in form of electrical energy and measured here. So in this way we are going to determine the velocity of waves, ultrasonic waves, and this length of the sample, and simply the time here we are going to measure by the stopwatch. So time taken to travel a particular ultrasonic wave to cover this length L, and simple V is equal to L by time taken. In this way we are going to calculate the value of the ultrasonic wave in any rock type material or rock strata, and on the basis of that he has in 1966 has calculated this concept and proposed this concept, and very simple and very easy also. We have already discussed about the crack. So you can see here the crack and the strength related coefficient. There is a continuous crack in this, and this weathering effect is increasing. So crack density is increasing, this weathering effect is increasing. Means there is a reduction in strength. Here we have direct relationship of the coefficient of weathering with respect to the compression strip. Here the coefficient of weathering measured in this way, you can see this type of relationship. So just reverse, here weathering concept, here the crack density increasing, the weathering increasing, because getting some open spaces for penetration of water and change of the mineral constituents of the rock. Another important engineering indices, we are calculating the slag durability index by using very simple instrument, and the concept was proposed by Franklin and Chandra in 1972. Chandra from IIT Kanpur and Franklin. This concept proposed by or method proposed by Franklin and Chandra later are received by this International Society ISRM, International Society of Rock Mechanics. This International Society of Rock Mechanics in 1983b accepted the proposed concept of slag durability. Slag durability is a very simple. Slag durability is nothing. It is a simply the measurement of the deterioration due to drying and wetting cycle. This drying and wetting cycle we are going to utilize experimentally by using some perforated drum, which we will discuss in our future classes during discussion regarding physico-mechanical property in detail. Here simply we are going to put the sample in such type of keg and allow for the constant time, and based on the reduction in the samples due to wetting and drying cycle, we are able to estimate durability, and reverse of this we are utilizing a weatherability. In view of engineering indices, the Gupta and Rao in 1998 has categorized different type of rocks and others and derived material in following groups as a fresh rock with some notations. Notation I have not taken here, that is not useful for this lecture. Fresh rock, then if this fresh rock subjected to slight weathering, it is recognized as slightly weathered rock, then moderately weathered rock, then highly weathered rock, then completely weathered rock. And then after completely weathered rock, this weathered rock changes in form of residual soil. So in this way we are able to categorize different type of rocks based on the weathering intensity. Slag durability index is a very simple. It is a ratio of weathered sample divided by original with respect to time of wetting and drying. So number of attempts we are going to put to recognize the weathering index in form of the slag durability index. Durability weathering is just opposite of durability. So the slag durability determine method suggested by many was calculated as percentage ratio of the final to initial dry rock samples. This indicates about the amount of materials released from rocks. Then when we are going to compare this, then we are utilizing as the relative slag durability index, and this slag durability index utilized to categorize different type of rocks for estimating weatherability in quantitative way. The slag durability also important to estimate indirectly about the strength of rocks. This concept we have prepared from the paper published by Gupta and Rao in 2001 and taken number of references, Franklin and Chandra, and some important, not all, Irfan and the Doreman and Roche et al. In 1985, then Lums, then Parker, then Honorade, then Mendes, then Mura, then Kohler, and finally these all references I have taken from the S. Gupta and K. S. Rao from paper Weathering Indices and their applicability, along with some material from the book and net. If we are going to conclude, we can say that the weatherability is dependent on the mineral constituent, texture, chemical composition and physical attributes of rock. Therefore, we are going to utilize three types of indices as chemical weathering indices, mineralogical and petrographical indices, and engineering indices. This weathering indices therefore divided in mineralogical, chemical and engineering indices, and this weathering indices had direct relationship with the mechanical response of rock strata because these indices indicating about the level of weathering impact on rock. The weathering index are the result of water-rock interaction or rock-water interaction presented in quantitative way to anyhow estimate the water-rock interaction impact on geoground. These indices are useful for engineering geological evaluation of geoground or projects. Dear friends, in this class we have discussed about weathering indices to evaluate semi-qualitative or semi-quantitative and quantitative estimation of water-rock or rock-water interaction. Thank you.